Hey everybody, welcome to this video on post-processing CinemaCraft 4. So I wanted to do originally these kind of behind-the-scenes videos linearly, where I talk about the recording and shaders and pre-recording and stuff, and then I do the editing and then the post-processing and stuff. But the problem is that in this case, post-processing is actually relatively straightforward, and doing all the recording information and things seems a bit complex. So I wanted to go ahead and do this video because it's not necessarily detached. It's just that it's relatively independent from the others because you can use the information otherwise. Also, it's raining right now. I apologize. Anyways, let's open up a video. So in my my project, I have one folder in my particular working set. It's actually quite large. About 600 gigabytes. It was actually touching 1.1 terabytes right before I released it because I had a lot of kind of intermediate files that I worked with. So I'm going to open up an original scene. And I guess I'll open up scene 5. So you'll notice it's called scene 5 120 FPS 2x. That means the actual video file is at 120 frames per second, but I multiply it by 2 times to get the real-time speed. So I go to interpret footage and set this to 60 because After Effects can only support up to 99 frames. So to make it easy, I just do 60. Bring it into a project. Set the time. Actually, let's set this to, well, let's actually not. I want to show you something. So this is, I probably should have left it in the image sequence, but you can see this is pixel for pixel what the actual image looked like that I recorded. This is actually what it looked like out of Minecraft. Okay, so what I wanted to show you was the extent of the aliasing. So this project, because when you drag a video to the composition option, it will make a composition exactly the same. So this composition is, as you probably saw before, 3840 by 2056, which is just less than 2160. That's due to when you record maximize window. So you can see the aliasing here, and if I set this project to 1920 by 1080 or something, and there's thunder there, and so I just go right click, transform, and fit to comp width, and so you can see it's now downsampled. So this is effectively a 2x2 SSAA in many ways. That's how you can kind of interpret it. So you have 4 times the resolution scrunched into the same image. So if I were to set this to draft, you can see basically no scaling. You can just kind of see how the image would look if I recorded it natively at 1080p. So it can make a pretty big difference in how it looks. So from here, there's a few things we can do. One is, well, there's basically 4 ways in this project that I use to reduce aliasing. One is you higher resolution and you downscale. Along with that, you can use the inbuilt SSA option in the shaders, where it basically renders a multiple of the resolution and scales down. So the most, in the particular version of the shaders I was using, 2 times is the maximum you want to use. A, it's the best looking. And B, it's the best performing because it's only doing 4 times the resolution instead of 16 times, and that number represents the scaling on each dimension. So if you have a video at 0 times SSAA, it's not on. 1 times SSAA is still really not on. It's just native resolution. 2 times usually would be 2 times the width and the height. So 1920 by 1080 would be 3840 by 2160. So your game is going to run literally, a quarter of the speed. If you did 3 times, that's then 3 times wide and then 3 times high. 4 times is 16 times higher resolution. So if you were recording at, if you're recording at 160 frames per second, you're now going to be at 10, basically. Anyways, that is an option in the game. So for this particular scene, I didn't use the SSAA. This was actually after this scene was recorded before I learned about that inbuilt SSA option. So in some of the later scenes I recorded at 2560 with the 2x2 SSA, which ended up having a sharper image. So in this case, I didn't have that, but I did record at 4K for downscaling to eventually 2560 by 1440. So I'm going to go ahead and set the project to 2560 by 1440. Go ahead and set that proper. And this image is going to be, this particular project is going to be at 60 FPS. So if we actually play it back at 24 FPS, you can see it's slowly creeping by. You can see some of the shimmer effectively that's going by. So you can see it's really, really slow, but that's with no frame blending. So if we set the video, to 25%, you can see it's quite shorter. We set the frame rate to 24, and set this to, I think, 50 seconds or something. So that's the project there. And if we zoom in and we turn on frame blending and turn on global frame blending, you can see it barely makes a difference. You can see it's basically just 1 pixel difference. You can see just how little that makes a difference. Now, it's because in this case, there's really no movement. The whole idea is if you have enough movement, then frames are overlaying other frames, and the samples kind of interact with each other. Again, this is kind of a technical rambling video, so it may just not make much sense. You can see a little bit there. So if we look on some of the grass, let's try to find some in focus maybe. This should be good here. If I turn off and turn on, you can just see it's a bit smoother. And that's because as you're moving through the world, different samples are applied. And if you look in the distance, you may see a slight difference. It's a little bit averaged out, but not that big of a difference. Again, because we're moving so slowly. So we've done downsampling, and then we have frame blending. So we have 2 other options. One, we have post-process anti-aliasing, and then we have CC wide time, which is basically a way to force a wider shutter angle than what's default, which is 360. So when you do frame blending, it's going to be 360 shutter angle, 360 degrees, where there's no frame wasted. All the frames are shown for that section of time. So sometimes I talk about samples of motion blur. So let's say you record at 240 frames per second, and you want to scale that down to 24 frames per second, you'd have 10 sample motion blur. What that means is for, I'm trying to talk with my hands actually when I'm doing voiceovers, which makes no sense, but let's say you're starting to count. So you got frame 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All that is blended together into one output frame. And then you have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's frame 2. And then 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That's frame 3. That's basically how it works in the background. Now, if you were to increase the shutter angle, if you were to shorten the shutter angle, because normally films are shot at 180 shutter angle, 180 degrees, and that usually means the frame rate is, you take the frame rate, multiply it by 2, 1 over the frame rate times 2, if you can visualize that. So if you're recording at 24 frames per second, you would record at 1/48th of a second, or 1/50th. So that would mean that in the case of those frames, let's see if I can figure this out again. That would be as if you had frames like 3, 4, 5, 6, maybe 7 would be frame 1, and then frame, 13, 14, 15, 16, 17 would be frame 2. So it's kind of like you're losing a little bit of the frames in the middle between the frames, but the instances, the frequency of those frames are the same. It's not like going 1, 3, 5, 8, 10. You're still going very fine frequency. So having a higher shutter angle, say 540 or 720 or something, would be as if frame 1 let's say, was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and that's blended all together into frame 1. And then frame 2 is like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25. That's kind of like frame 2. So they overlap. That has benefits and downsides. In the case of this, the benefit is the fact that as these little tiny little frames move, they're overlaid into each other. So I'm going to give you an example. I'm going to go to Effect Time, CC Time, and you can see using 1 makes a little bit of difference. But if we zoom in, I'm actually already zoomed in all the way, and we turn on and off, you can just see it's a bit smoother. And that's because as the frame, as it moves to the left, effectively, it's being blended into other frames. So if we go 2, like that, you can see it's a bit smoother. Now if we go 3, which is really, really long, you can see it's almost butter at that point. Now there's a couple downsides. One is the fact that your motion is going to look really, really blurry. Now if I were to, I'm going to just have that render out as I talk. So one of the big problems is that the leaves, which are really close to the screen, they're very detailed. I want them to look sharper. And so I want them to have a lower shutter angle. So what I did was I actually masked out the top of the trees, but left the trunk because it's angled. Left that with CC wide time. And you can see just it's so blurry at this point. And so that let me have all the shimmer, all the aliasing basically eliminated really easily. And then the leaves are still clear. So if we play this back, you can just see the leaves look like they're in slow motion or something. So what I had to do was basically make 2 copies and mask that out. But if you look at the trunk here, you can see it's so smooth now because all those frames are basically blended into each other. Now the other thing is if you look in the background is really, really calm. I mean, there is a little bit of shimmer, but that's zoomed in. Let's do 100%. You just see how quiet it is back there. Now, let me turn off this effect. Play it back. I'll have it render out, but you'll get the idea. So in the background, you have shimmering because you're talking about pixels that are very far away, or pixels that effectively are very far away from the screen. So there's a lot of variances. There's a lot of differences between each pixel as it samples more and more distance. So that's like if you use a really high resolution texture pack, you get much more shimmering on textures far away than you do up close, because the ones up close effectively are occupying more pixels, relatively speaking, than ones in the distance. See, that's the idea of super sampling in this case, or mip mapping. So in some ways you can think of, I don't know, this is maybe mip mapping for time. It's a bit convoluted. So like I was talking about with the texture packs, you can have a texture really up close. Let's say it's, I don't know, 32 times the texture pack. That may be occupying, 64 by 64 on your screen. But that same 32 by 32 texture, effectively like a kilometer away perhaps, is occupying like a 3 by 3 pixel square on your screen from that point. So those pixels are going to be moving much greater distances much more quickly. So if we play this back, you can see there's a bit more shimmering on that area. Also, I made a really stupid mistake. I turned it to draft instead of turning off frame blending. Let's try that one more time, and I'll skip ahead. Well, you can obviously see it's already rendering much faster, and you can just see how big of a difference there is. So that's what it looks like with no frame blending. If we turn on frame blending, you can see it's slightly calmer. It's not that big of a difference, but it's slightly calmer. If we play that back, you can see it's still really jittery. And then if you turn on your effect, it just is so much better. Just like that. And that looks so calm in comparison. Now, again, you have the downside of it blurring your leaves up here. But down here, I usually left the grass untouched because it wasn't moving fast enough to really be that big of a difference. And on top of that, your focus is up top. So that's basically most of what's going to work. You also have a plugin that I found called Olm Smoother. And if we turn off CC time, I can just show you how big of a difference it can make. So the smooth range is how far it looks for stair stepping. So if you had stair stepping on a really sharp angle, you may want to have a large range that looks at. So you can see it's not perfect, but it does a pretty decent job. And it's a bit slow. It's about 1 second a frame sometimes. If we turn off frame blending, because that doesn't make much big of a difference. You can see it does a pretty good job. That's with no CC time, and this is just with the anti-aliasing. Unfortunately, this really should just be another tool you use, especially for a slow-moving scene, perhaps. Because here's the problem. The Olm Smoother really is only referencing the current frame. It's not looking at other frames. It's not like it's SMAA T2X or 4X or something, where it's actually doing frame projection on previous frames and previous samples. So it's only looking at the current frame. So it's making guesses. So if, things are changing, then it's not going to be very good about where to place a blur vector. I don't know if that made any sense, but I'm just trying to make it kind of a bit simple to understand. The idea is it's making a guess on the current frame, but CC time is using all the frames all together to create a very averaged look. Olm Smoother is not going to make your video look cleaner due to jitter or shimmer. It's just going to make it look probably less. It's going to make it look less shimmery due to contrast, so it's going to dull edges a bit, but don't expect it to make, stuff in the distance look clean. It's just not. CC time is a much better option for that, due to the fact that it's actually referencing real data in the scene, and you can just see how calm it is. So this was my most challenging scene just because I had parts that I actually wanted to be clean. So I'm just going to go and open up one other video before I end this. Scene 4. This was probably the perfect storm in this case. So let's go ahead and set this to 60 FPS. Let's bring it into a project. So this should be, that's right, time stretch, 25. Let's make our project a little bit shorter, about 15 seconds, 24 FPS, and we're done. Okay, so let's set it up the same way. We're going to turn frame blending on the layer, and we're going to turn on frame blending for that particular object. So if we skip ahead to time so there's no issues with the scene starting, you can see it barely makes a difference. Some edges are 1 pixel off or something, but it's still sometimes good to have. So we can add the anti-aliasing filter and bring this up to about 20 or so. You can see on this edge here, it really cleans up that edge there, even though your focus really isn't on that area. And on this area here, you can see it does a pretty good job cleaning up that edge there, which is definitely high contrast, and it's like the center of the image. On other parts of the image, it really doesn't make that big of a difference. It doesn't make that big of a difference on other parts of the image, and in fact, it may make it worse because it's trying to anti-alias corners, which doesn't really make any sense. So really, your best bet is actually CC time here. And in this case, you may want to set it to 2 times. And we'll turn on frame blending and maybe Olm Smoother 2. And if we let this render out, we'll be able to see just how big of a difference it makes. And then we'll play it back without any of those effects to give you an idea of how big of a difference doing these kinds of blending methods can make. So you can see it's really, really smooth here. And if we zoom out to 100%, which is pretty much what people are going to be looking at, you can see it's, except for a little bit of a tiny flicker there, it's almost perfect, really. I mean, it looks like CGI, perhaps. Something you wouldn't really notice. So let's turn off frame blending. And let's turn off the effects, and let's play that back. Obviously, it's rendering much quicker. And you can just see how big of a difference that looks. I mean, the shimmer in the trees, because even though they're blurred out, it's blurring whatever it was looking at. And again, just like with the anti-aliasing shader, or anti-aliasing filter, it's working with what it's seeing. And if what it's seeing is shimmery, then you're going to have a shimmery blur. Blurring does not fix it. Just in the same way you can't blur an image to get rid of aliasing. It just makes it blurry aliasing. So you can see there's a really massive amount of shimmer here as everything is shifting. So let's turn on frame blending and the effect, and you can just see it's like night and day. Even if there is shimmering, it's much smoother and much more organic. You don't point to it and think, oh wow, that really looks ugly. So this was something I had to do basically for every scene. And let's look at the shimmer in the trees again. You can see it flows much more smoothly. It's not something you really comes out to you and say, oh, that looks, super computer generated. I mean, the point of this project really wasn't to make it look real, obviously. It was to make it look as good as possible for in-game. This was all in-game, recorded with Minima. And the idea could be, someone could just tell me, well, why didn't you just do it in a CGI program? Well, then what's the point of really doing it? Because it's just in a CGI program. Well, that's about it. I hope that gives you guys kind of a pretty decent introduction to kind of what I was doing in the background to make the images look as clear as possible. Having a really wide CC wide time isn't always the best case. This is actually on number 3 right now. You can see there's almost no shimmer whatsoever, and that's at 200%. If we zoom out, you can see it basically looks perfect. So, for some scenes where there's not a lot of movement, you won't notice the fact that there's a really wide shutter angle. But in this case, really works really well. In that overhead top shot, that was actually with a 180 degree shutter, where I basically worked on it at 48 frames per second and brought it into Vegas and processed it to 24, where I was skipping every other frame. Anyways, I tried not to go into too much detail, but still try to give you guys a pretty clear idea of what was going on. I hope to do one talking about the actual editing process, and then one maybe about the recording and preparation or pre-production. But that one takes a little more thought to it, because this video was a little more straightforward. Anyways, if you have not seen the video, then I don't know why you watched this, but click the link in the description for the Olm Smoother plugin, and also a link to CinemaCraft 4. Or you can just go to my main channel page. It's the trailer. Anyways, thanks for watching, and I will see you later.